Okay, so today we're going to be doing 6.6 and we're going to be learning how to find the area of a triangle. So some of you are thinking, well, I already know how to find the area of a triangle, but I'll teach you why we're learning something a little bit different today. So we're going to be able to find the area of any triangle after today, and then we're also going to learn the law of sines and how to apply the law of sines. So we use the law of sines to look for missing side lengths or missing angles, and we'll learn about that in a little bit. So first of all, I want you to recall that if you know 3 parts of a triangle, then you can sometimes solve the triangle. So sometimes you can solve for missing side lengths, and you can determine its complete shape. So this is what you did in secondary math 2, tons. Like we spent an entire unit on similar right triangles, similar triangles, when you have angle bisectors. So that's what I'm talking about. And just recall that we used side, angle, 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 side, and side, side, side. That's what all of this was about. Now, can anyone remember which one we can't use to prove that triangles are similar? This is just seeing if you remember. Side, there. No, wait, angle, side. That's okay, because that would be 2 angles. Anytime you have 2 angles. Angle, side. So I'm going to write that like you'd write this. Angle, side. Now, how do we, that's a bad word, right, guys? So that's how an easy way to remember, like, if you have an angle and a side, if you have an angle, one angle, and then a side in that order, and then you can't tell for sure if triangles are similar. You will see that come up on an ACT or something. So if you see it written in that order, you just say to yourself, that's a bad word. We can't use that. Okay. So you would just say, it doesn't mean they're not similar, though. That's the common error. It doesn't mean they're not similar. It just means we can't tell for sure. Does that make sense? Okay. We don't have enough information with angle, side. Okay. But that's really besides the point of what we're learning today. That's beside the point. I saw that back there. Sneaky, though. Very sneaky. Okay. So now, a lot of you, like I said, a lot of you have seen this. I mean, yes, you've definitely seen this. So a lot of you are saying, well, I already know how to find the area of a triangle. And yes, you do. But you only know how to find the area of a triangle when you're given the height. So looking at this, we know the area of a triangle, as long as we have the height, is 1/2 times base times height. So that was for given this height, this altitude drop down. So given this height, we can use this formula. Now what if I was to erase that middle line, beep, 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 erase it, it's gone, and we then don't have a height, correct? So we wouldn't be able to find the area. So that's what this new formula is for today. So really, this is now how you can find, not given a height, you can still find the area of a triangle. You're just going to use this formula now. So area is equal to 1/2 times B times C. So that's side BC, and then it's times by sine of A. So notice B and C, so side B and C. Well, first of all, side B is across from angle B, and side A is across from angle A, and side C is across from angle C. So notice the way this formula works is 1/2 times B times C. So B and C are right here, B and C, and then the angle between them is A. So we always take the sine of the angle between the 2 given side lengths. Does that make sense? So now looking at my next area, well, it's the same thing, it's just written a little bit differently using the other 2 sides. So we have area is equal to 1/2 times AB. Well, AB, between that would be side angle C, so we'll do sine of C. And then once again, area is equal to 1/2 times AC. Between AC would be angle B, so sine of B. So we'll literally just plug this in. Now, I don't think you really care that much, but where this comes from is from this original area formula. So when we dropped this down, if we took an angle theta, we could find the opposite over hypotenuse and all that, right? We could find, so sine is O hex, so we would do opposite over hypotenuse. That's where this formula derived from. So just so you know where it came from. Comes from this, but I know most of you don't care. You're just like, I got that formula, we're good to go. Okay, let's go ahead and apply this then. If you guys all have this written down, can I go to my next slide? Okay, one more second. So now remember, okay, this is what's important though. to use this area formula here, we would need to be given two sides and then the angle between those two sides. So to really be able to find it, we need it to be set up that way, which all of our problems will be. And this will work for all triangles. So like I said, you'll want to know this formula or how this works for the ACT because there's a good chance you'll run across it. And you guys are taking that, I think, next week or something. Okay, let's go to the next one. Here we go. Let's apply it. So now once again, what is the area of triangle ABC to the nearest 10th? So now notice, this does not have a height. We don't have an altitude drop straight down with the right angle, so we can't use 1/2 times base times height. But that's okay, we learned this new area formula. So we're going to do area is equal to this side times this side. So 10 times by 5 times by sine of the angle between. So sine of what? Sine of what? The angle between the two sides.
Okay, so that's 31 B.
So this side's 10, this side's 5, guys. What's the angle between? 31. Sine of 31 degrees. There'd be no other way of finding out really, well I guess, yeah, that would be kind of difficult. Yeah, we wouldn't be able to find out any other angles. Okay, does everybody see what I just did there? Okay, so let's calculate that. Now it's important that you put your calculator in degree mode since we're actually calculating, let's see. Yeah, sorry, we're finding the area, we just need to make sure since we're plugging in this 31 degrees that we have our calculator in degree mode. So, area will be equal to...
Wait, but you forgot your half.
Oh, thank you, 1/2, forgot that. Yes, I did. What a baller, she's awesome. Thank you for saving us. I would have been like, what's going on? So we forgot our 1/2, we're not going to forget that. Thank you, Marissa, for saving us. So 1/2 times by 10 times by 5 times by sine of 31. Practice plugging it in. 12.87 something or other. We'll round to the nearest tenth. So area is equal to 12.9. Any questions? I'm a little bit concerned because I messed that one up and then we were all kind of like sitting there like didn't understand. So are you all okay? You're all okay? You're sure? No questions? Okay, you're going to do problems 1 through 4. So you're going to do problems 1 through 4 now on the worksheet. Now make sure you start on the practice side, so go 1 through 4. And I'm not going to give you a whole lot of time because these are straightforward, quick. Okay guys, let's bring it back together. Now as you can see with that, it's easy to get really comfortable just like I did and forget little things like the 1/2, but those are essential things, so just don't get going too fast.
So it's always going to be sine.
Right, it's always going to be sine. Yep. Alright, so now, I wrote the area split up like this, right? So area is equal to 1/2 BC, sine of A, and so on, all of these. If they're all equal to the area, though, then they're equal to each other, right? So, once again, like I said, these are all equal to the area, so they're all equal to each other. So, I just wrote it like this time, because this is how it's written in the book. I just split it apart to show you, really, that's all we're doing here is, it depends on which side we're given, but we know that how this works. You're going to take 1/2 times the one side times the other side, sine of the angle in between. Okay, but now this area formula, it actually yields something really cool. So what they found is if they went through, so what these really cool smart mathematicians found is that when they went through and divided all of this by 1/2 ABC, so dividing all this by 1/2, now this you might not necessarily need to write down. I'm just showing you where this next formula or this next theorem came from. So if we went through and divide all of this by 1/2 ABC, then right here, our 1/2s divide out, our B divides out with B, C divides out with C, and left would be sine of A over A, correct?
Yeah.
Then over here, our 1/2s divide out, A's divide out, B's divide out. Oh, no. Not B's divide out. B's divide out, C's divide out, and then B's left sine of B over B, right?
Yeah.
Okay? So then over here, 1/2s divide out, our A's divide out, our B's divide out, and left would be sine of C over C. So what's really cool is this is the law of sines. So now this is the law of sines. Sine of A all over side A is equal to sine of B over side B, which will be equal to sine of C over side C. So it just is proportionate. So we can set it up like this. So we're going to use this to find missing side lengths or missing angles. And you'll see how we do that in just a second. But really, the most important thing that you understand is that we can set this up proportionately. And I think one of the biggest misconceptions, and most secondary math 2 students have a hard time with this at first, but I'm hoping you guys won't. So even though I have all 3 of these are equal, we could just do 2 of them are equal, right?
Yeah.
So we could do those 2 are equal, so sine of A divided by A is equal to sine of B over B. And we could cover up this sine of B over B, and we could just do sine of A over A is equal to sine of C over C. So any combination of this will work, and we usually, we could use all 3, but we'll usually just use 2 of them, and then we can solve for missing side lengths. So let's do that in the next problem. Do you guys have the law of sines written down?
Yeah.
Okay, but before we do that, I guess I should talk about the only time we can use the law of sines is in these 3 situations. So on the test, we're going to give you these triangles and ask you to find the unknown values. You're going to have to know if you can even use the law of sines, because next time we're learning the law of cosines, and you'll have to know if you can use the law of sines or not. So you don't have to write down all the gory details of this, but at least write down the gist of it. So first of all, when can we use the law of sines? So first, you can use it if you're given 2 angles and any one side. So or any side. So if you have 2 angles and a side, you can use the law of sines. That's the first way you can use the law of sines. Second, if you're given 1 angle and 2 sides where the angle that you're given is across from one of the 2 sides, and if the angle is obtuse. So like I said, for example, I kind of drew this triangle just to give you an example. If we were given this angle A, and across from it we were given a side, and then we were given one other side, see how angle A is obtuse, meaning greater than 90 degrees? So we can use the law of sines, no problems. Okay? Now, the next thing is, if you're given 1 angle and 2 sides, and if the angle is across from one of the 2 sides, so for example, if the angle is across from one of the 2 sides, so in this triangle we have given angle B, it's across from B that was given, but notice this angle is acute, meaning it's smaller than 90 degrees. So if it's acute, and it's across from, and you have a side across from that, if that side is greater than the other given side, so if B is greater than C, then you're good to go. You can use the law of sines. Okay? So if it's acute, the side across from it has to be larger than the other given side. Does that make sense? Okay, because if not, we could run into the ambiguous case. So it's kind of hard to explain it because we're not actually going to get into it. Honors gets way far in depth with the ambiguous case. We're not getting into it in regular. You'll get into it in pre-calculus, but we're not going to get into it, but I felt like I had to talk about it at least so that you're not like, well, Miss Christensen didn't even say anything about that last year. What's she talking about? Does that make sense? So you are going to run into the ambiguous case at some point. You'll learn about that next year for those of you that are taking pre-calculus. Now, what that means is, we'll get to it later. I'll explain a little bit further, but we're not going to run into it in this class.
The first one, 2 has to be smaller than what?
2 angles. That's it. Oh, sorry. I'm like shorthanding here. Miss Christensen's own personal shorthanding. So this is just angles.
So 2 angles
Right, and any side. If you're given 2 angles and one side, you can use the law of sines. Yes.
With the 1 angle on the side, the one acute one,
Uh-huh.
the opposite side has to be bigger.
Then the other side. Yes. Good. Yep. Now I'll explain why this ambiguous case comes about a little bit more in a later example, but we won't get into the gory details. We're not dealing with it in this class, okay? So I'm sorry for those of you that you're heartbroken, but you'll learn about it one day. Okay? Okay. Yeah, so like I said, we're not going to get too far in depth with it. So these gory details in here aren't super important, but is everybody good?
No.
Not quite. Okay, so it's not going to be that complicated, guys. So I just wanted to mention the ambiguous case. So like I said, next year you're not like, Miss Christensen never said anything about that. So, okay.
I don't really think our list is that high.
Well, some. Okay. So now looking at this. Alright, so it says find the unknown variables. So you're trying to find x and y in this one. So looking at this, first of all, you on the test you're just going to be given a triangle that looks like this. So now you would look at it and say, I'm given 2 angles and a side, right? 2 angles and a side. I'm going to use the law of sines. So now it's pretty simple for the most part. So we can find x or y. It doesn't really matter whichever one we want to find first. So I'm going to go ahead and find x first. But like I said, either way will work. So we're going to set it up. So we're going to do sine of 32 degrees over, so the angle, sine of the angle over the side across from that, which is, what's across from 32, guys?
39. F? Oh, F.
X, yep, which will be equal to the sine of,
The sine of 39.
the sine of 39, good.
Over 4.
The sine of 39 degrees, and across from the 39 degrees is 40 centimeters. And I'm just going to write 40 on the end. My answer, I'll add in the centimeters. Okay, so over 40. We're just trying to find x, right? Is everybody okay with how I did that? The sine of the angle with the side across from it. These ratios will end up being proportionate, so that's why we can set it up this way. Okay, so we're solving for x. Now, pay very close attention. If you have questions, make sure you ask. So we're solving for x piece by piece. So we are going to cross multiply, right? Okay, so, my secondary math 2 students do not struggle with this, but a lot of my secondary math 3 students do. So make sure you ask if you have any problems with what I'm about to do. So I'm going to get rid of my fractions by cross multiplying. So I'm multiplying both sides by x, but I'm not going to write it over here because it's going to divide out over here, right? I'm going to multiply both sides by 40. Once again, I'm not writing it on this side only because it divides out. So we did multiply both sides by that. Alright, so now on this side, so yes, in this problem I'm showing all my work. So now on the left here I have 40 sine of 32 degrees is equal to x sine of 39 degrees. We're trying to solve for x. So right here in this particular problem, how do we get x alone? Good, divide by sine of 39 degrees. So now we're dividing by sine of 39 degrees, dividing both sides by sine of 39 degrees. And now on this side, the nice thing is x is all by itself, those divided out, right?
Yeah.
So now, literally, all you're going to do is type into your calculator. So x is alone, so I'm erasing this just to keep it pretty. You're going to type in 40 sine of 32 divided by sine of 39, because x is all by itself. That's all we were trying to do. So you typed it into your calculator. Let's see if you get it right. So practice typing it in so we can make sure we're good. Yes. Okay, what'd you get? 33.68, whatever, we're going to round to the nearest 10, so x is equal to 33.7, and then it was a side length, so it was, and we were dealing with centimeters, so centimeters. So x was equal to, I'm going to put it in, 33.7 centimeters. Sweet. Okay, questions? All right, so now we need to find y. Same way, we're going to go about it the same way. So first of all, we know that the law of sines works like this. We'll take the sine of the angle divided by the side across from that. Do we have this angle right here? Do we have angle P? Yikes, we don't have it, but what do we know about the angles of a triangle? They add up to be 180. So will this one be hard to find? No, so this will just be this angle, angle P, is going to be 180 degrees minus 39 degrees minus 32 degrees. What's angle P? 109. Was it 109 exactly?
Yeah.
109 degrees. Okay, awesome. So now we can set up our law of sines the same way. So sine of the angle over the opposite side will equal all the sines of all the angles with divided by the opposite side of that angle. So we're gonna do, now we can do either or. We can use either angle, but I'm gonna use, let's just start out with what we're trying to look for. So we're gonna do sine of 109 degrees over y is equal to, now we could use either, like I said, I'm going to go with this 40 so I'm not dealing with the decimal. And not only that, but if you use this decimal to solve, you need to be plugging in the entire decimal. Does that make sense? Not the rounded answer. You need to put in the entire decimal because rounding can turn out to be differently if we don't put in the entire decimal. So if you're going to use 33.7, you need to actually put in what the entire decimal was. So let's just use the 40. Yeah? So sine of 39 over 40. Does everybody understand what I just said?
Yeah.
Over 40. Alright, so now we're going to multiply. We're going to cross multiply. So I need to give myself some room. I hate how little room there is on here. So we're going to cross multiply. So multiply both sides by 40. Divide that over here. Multiply both sides by y. It divides that over here. So I have 40 sine of 109 is equal to y sine of 39 degrees. So now how do I get y alone?
You divide it by
Divide by sine of 39 degrees. Divide by sine of 39 degrees. So now y is all by itself. Those signs divided out. So what's y? 60.1 centimeters. Did we find the whole triangle? Yes. Could we find the area? Yes. Questions? Let's do one more. Like that. Okay. So I'll give you a second to get this down. I'm going really fast. I need to slow down, so I apologize. I get too excited at the end of the day.
It's right.
It is. Okay, so once again, on the test, we're just going to give you this triangle. And the first thing you're going to look for is, can I use the law of sines? So you'll say, well, there's two angles and a side. So yes, we'll use the law of sines. Okay, so now, we're just trying to find x in this one. Luckily, we don't have to find the full triangle in this one like the last one. This one's going to be a lot quicker. So, but we could find the full triangle, but we're not asked to. So we are going to be doing, let's see here. So we're going to be doing sine of 80 over x is equal to sine of something over 10, right? We've got to be using this angle for sure, right? Because 10 is the only side we were given, right?
Yeah.
So we definitely need the angle across from it. So let's find that angle real quick. Remind me how to do that.
180 minus 80 and it's 65.
180 minus 80 minus 35 is 65.
Yeah.
So this is 65 degrees, and then we're good to go. So sine of 65 degrees over the side across from it, so 10, will be equal to the sine of 80 over x. Now, could I have set it up, the sine of 80 over x is equal to the sine of 65 over 10? Yes, right? I mean, that's kind of obvious. We're past that point, but I just had to ask to make sure. It doesn't matter which way I set it up, right? Okay, solving for x piece by piece, so we'll multiply both sides by x. We're cross multiplying, multiply both sides by 10, so that divides out over here. Now I'm hoping you guys are at that point where I can just kind of skip. So now on this side, what am I going to do to get x alone? Divide by sine of 65 degrees, so we have x is equal to 10 sine of 80 degrees divided by sine of 65 degrees, and we get x is equal to
It's 10.9 centimeters.
10.9. Done. 10.9. Now, I'm going to ask, does this seem reasonable? So it's kind of nice because with the law of sines, you can kind of check your answers in a sense because you can see if at least if your answer seems reasonable. So now looking at all of these angles here, 80 is our largest angle, right?
Yeah.
So across from 80 is 10.9, and then 65 is our next largest. Across from 65 is 10. Was 10 less than 10.9? And was that angle less than that angle?
Yeah.
Yeah, so it's kind of a nice way of checking, does my answer seem reasonable? Because if we got 9 was across from 80, that wouldn't make sense, right? Because 65 would be a smaller angle, it better have a smaller side. Does that make sense? So you can just kind of see if your answers seem reasonable. Okay, so last 2 examples. So now this time we're asked to find angle T. So you guys stay with me. These ones are different, and then I'll set you free to work the rest of the time. I promise you'll finish, and in class you'll have tons of time. So now looking at this. So this time we're asked to find angle T. So now once again, let's see if we can even use the law of sines. So we were given one angle and 2 sides, right? And look at it, is the angle that we were given across from a side that we were given? Yes. Is that angle obtuse? Yes, so we're good. Like we don't even have to worry. There's not an ambiguous situation here. So we can definitely use the law of sines. So let's set this up. So we're trying to find question mark angle T. So we're going to do sine of question mark over which side? 7 will be equal to sine of 110 degrees over 9. So this time we're trying to solve for question mark, right? Is anybody bothered that I'm leaving it as a question mark and not putting it as an X? Same thing, right?
No.
Too bad. Just kidding. Okay. So we're trying to get question mark alone, right?
Right.
So we're going to cross multiplies, right? Okay. Multiply both sides by 7, multiply both sides by 9. Our denominators cancel out. So on this side, very good. So I'm going to quickly write this one out. So we have 9 sine of question mark is equal to 7 sine of 110 degrees. So now, like Andrew just said, we need to get question mark alone piece by piece. What am I going to do? Divide by 9. Divide by 9. So now we have sine of question mark is equal to 7 sine of 110 over all over 9. How do we undo sine? Inverse sine. Yes, do you have a question?
So you don't want to figure out what 7 sine of 110 divided by 9 is yet?
We could calculate it, but it'll be just as easy for me to type it into my calculator as inverse sine of all of that. But if you type in the exact decimal of that, that'll be fine as well.
Okay.
So I'll just leave it like this, because like I said, for me, it's just as easy to plug that back into my calculator. So to undo sine in this one, we're going to have to take the inverse sine. But on the other ones, we didn't have to take the inverse sine, right?
Right.
But this one we will, because we have the sine of question mark. The only way to undo sine and get question mark all by itself is the sine inverse. So I'm taking the sine inverse of both sides. So now we have question mark is equal to sine inverse of 7 sine of 110 degrees all over 9. And then I'll just type that into my calculator. Question mark is all by itself. There it is.
Well, 46.696.
So T is equal to 46.95.
I just rounded it up.
Okay, so we get T is approximately equal to 47 then, right? Because
Yeah.
this would round up, so 97 degrees. So T is equal to 47 degrees. Could we find now angle S if we wanted? How? 180 minus 47 minus 110. That easy. Yes. Okay, any questions? So this would be 23 degrees. If we wanted to, like I said, 180 minus 47 minus 23, sorry, 180 minus 47 minus 110 would be 23. Okay. Last example, and then I will pretty much let you work. Last one. Okay, so this one. So it says, find all the missing values. You will round to the nearest 10. So this time we have to find all the missing values. So we're going to find the missing sides, the missing angles, and so on. Now, first things first, we'll ask ourselves, how are we going to do this? So we were given one angle and 2 sides And the angle that we were given, is it across from one of the sides?
Yes.
Yes, but it's acute, right?
Yeah.
Okay, but is it, so it is acute, yes, but across from that acute angle, is that side larger than the other side that was given?
Yes.
Yes, so we won't run into an ambiguous case here. So once again, we can use the law of signs, no problem.
Okay.
So let's set this up. What do you want to find first? X, so you told me how to set it up real quick.
You have 28 sine of 43. Oh no, sorry. The sine of 43 divided by 28
Okay, divided by 28, very good, is equal to
equal to sine of x over 27.
sine of x over 27. Does everybody see how we set that up? Cross multiplying. So we're going to have, so I hope you guys are at this level. Hopefully I can skip. We're multiplying both sides by 27. I'm going to leave the 28 over here because that's what we're going to do anyways, right? Is divide both sides by 28.
Yeah.
So, okay. So we're going to have 27 sine of 43 degrees. 27 on top with it because we're multiplying both sides by 27. It divides out over here. Once again, I'm not going to multiply this 28 over just because I'm going to then redivide it, right? So I'm going to just leave it. Which is equal to sine of x. How do we get x degrees by itself?
You have to divide by the inverse of sine.
Good. We have to apply the inverse sine to both sides. So inverse sine, sine inverse. So that undoes that. We have x alone. So we're putting into our calculator. X is equal to sine inverse of all of that stuff. 27 sine of 43 divided by 28. 41.1. So if you want to put a little star in your notes, I promise on my life that you will definitely see something where you have to use the law of signs on an ACT. Promise. So that's just one good thing to keep in mind. You'll go in, the first thing I do when I sit down for the ACT is I write out a couple formulas that I know I'm going to probably be using. So, just saying. I promise you'll see the law of signs at some point on that ACT. Okay. So now we know that x is equal to 41.1 degrees. Let's find this angle. How will we find it? So take that, tell me what that is. So we're doing 180 minus 41.1 minus 43.
95.9.
95.9. And now can we find the side across from that?
Yes.
Yes. So we'll be doing sine of 95.9 over x is equal to, now we can do either or. I'm going to go with this one. So we have sine of 43 degrees over 28. And then cross multiplying this out. So we're going to be having 28 sine of 95.9 is equal to x sine of 43 degrees. And then divide both sides by sine of 43. Oops, where's my little... Sorry, I'm going too fast. So I multiplied both sides by 28, so it divides out over here, multiply both sides by x. And now I'm dividing, since I have x sine of 43, I'm dividing both sides by sine of 43. So now we have x alone, which is all we're looking for. So what is this side?
Uh,
40.8. Okay, so now, once again though, a lot of people on accident, they think that they can use the Pythagorean theorem for these type of problems. Definitely not. You guys, you can only use that for 90-degree right triangles. So we would have definitely had to use the law of sines to solve for the side lengths, right? Okay. All right. Do you guys want me to explain more about the ambiguous case? Are you ready to work because you don't care?
we're not going to do it.
Okay. So we're not going to do it so we don't care. All right, fine with me. So you're going to, number 7, you're just going to not do. Because you're right. You couldn't, just say you can't do it by the, you saw that you couldn't do it by the law of sines, right? Because you were given an angle and two sides, yay, but the angle that you were given is not, oh wait, no?
There's no opposite.
Right.
So it's just
The angle that we're looking for, there's nothing across from that, right? Yes. Okay.
So there is a way to do it though.
Yeah, we'll learn that next time.
Yeah.
So go to number 11.
No, it's number 7.
Wait, find that.
No, you just do the front side, guys. Do front page of worksheet. If you, okay, so you have an online assignment, but if you choose, I will let you do the back page of this instead of the online assignment. This will be counted if you want to do the back side instead of the online assignment, or if you want to do the online assignment.
I say the backside and let it go.